Okay. Hello, welcome. Welcome to today's webinar, Making Economic Health Models Shiny, our experience helping companies transition from Excel to R and Shiny, brought to you by the R Consortium. The R Consortium supports organizations developing R infrastructure through grants and sponsorships worldwide. Please visit our website to learn all the details and how your organization can become a member. My name is Jesse Kasman, today's moderator. You can ask questions through the Q&A icon at the bottom of your screen. We consider webinars to be an extension of the community. Please do ask questions. Okay, let me introduce our two speakers. We have Dr. Robert Smith, Director, Dark Peak Analytics. Dr. Smith specializes in the application of methods from data science to health economic evaluation in public health and health technology assessment. He holds a PhD in public health economics and decision science from the University of Sheffield and the University of Newcastle. We also have Dr. Wael Mohammed, Principal Health Economist at Dark Peak Analytics. Dr. Mohammed holds a PhD in public health economics and decision science and worked at UK HSA during the pandemic. He's also the director of the R4HTA Consortium. Okay, gentlemen. Robert, I believe I'm handing it off to you first.
Thank you very much, and thanks for the invite. It's great to be talking to everybody. Thanks for joining us on the afternoon here in the UK. I'm going to start by working through kind of some of the history behind how we've got to where we are, and then hand over to Whale, who's going to talk a bit about the publications that we worked on and some of the software. So it's very much in the lens of how we are trying to transition the industry sector that are building these health economic models and submitting to regulators, how we're going to gradually shift those from being Excel based to being R based, and the role that Shiny plays in that process. So a little bit about me. I'm director at Dark Peak Analytics and specialize in building models in R. I was at UKHSA during the pandemic, and people probably know me best for kind of shouting into the void for years on the use of R for HTA and health economics. And for a while, this did feel like it was a bit of shouting into the void, not getting a huge amount of traction. And in the last few years, it's really taken off. So as with the pandemic, exponential growth is a incredible thing. And so we're really seeing the effect of those earlier efforts kind of come through now. So hand over to Whale just to introduce himself very briefly before I carry on.
Thank you, Rob. Hi, everyone. My name is Wael Mohammed, and I've recently finished my PhD in public health economics and decision science. In the PhD, I kind of focused on calibration methods and calibrating decision analytic models. And that kind of, captured my attention or directed my attention to how efficient our models are. And obviously with calibration methods and, one other bit of what I was doing in the PhD, which was extending the value information analysis framework to calibration and calibration and the calibration framework. Both calibration and VOIs are resource intensive pieces of processes, and then therefore with resource intense applications, we need resource efficient models, and this kind of took me to the track of being more interested in making our code very efficient, including the use of C++ and the most efficient ways of programming models in R. I will let Rob continue and see you in a bit.
So just by way of a bit of background, just to give the context. So for years we've been kind of operating in this system with the top diagram here, where for a lot of the analysis that's being done for health economic modeling, you'll have potentially some survival analyses or time series analyses being done in programs like Stata, and then you'll have the results from that being pasted out into Excel, where a simulation model is built and run, often using Excel VBA code. And then the outputs from that might be plotted and visualized in a separate sheet or in an entirely separate document sometimes, and then taken from there and copy pasted into a Word report. and also displayed as a PowerPoint, copy pasted into a PowerPoint. And so this whole process is incredibly error prone because there's a huge amount of potential for human error and copy and paste. It's also really time consuming. So if we get a new cut of trial data, for example, or some new information on costs or health state utilities, all this analysis, anything that is to the right-hand side of what's changed, will need to be redone. So we need to redo the stats, insert this into the model, rerun the model, copy paste again, and output. And so in the modern day, this is quite a slow and expensive and error-prone system. And so the idea is to try and shift from this method at the top here more towards using R to develop a pipeline for these models, where as new data comes in, stats analysis is run either on the click of a button or automated. The results from those kind of statistical analyses are fed into the simulation model directly, and that's rerun. New visuals are created using packages like ggplot and inserted into our Markdown or Quarto reports, and those can be visualized using Shiny, and the whole model can be run in kind of real time, as it's much faster in R. So really the aim is to shift from the upper process, which is very error prone, time consuming, to the lower process, which is much more efficient and less error prone. And a lot of what we have been spending the last sort of 5-6 years doing, maybe even longer, is kind of going around and trying to kind of spread the message about R being much more flexible, much stronger, the visuals looking better, the computational speed being faster, being faster to develop and iterate as we build packages and rely on external packages, it being much easier to make things transparent via open source code and GitHub and things like that. But the really big stumbling block, the really big tricky thing that we find throughout the whole kind of last 5 to 10 years has been this familiarity issue. Because Excel is familiar to a lot of people, there's a big barrier to entry for any new software. And so we're going to talk a little bit about that today and our kind of impression of that and how we've tried to mitigate that through the use of things like Shiny, but also training and other things. So it's important to recognize when we're talking to other groups that are kind of well versed with coding, sometimes there's a tendency for us to be kind of a little bit in a little bit of a bubble where we think, oh, okay, everybody can code, that's fine. Like everybody should just do stuff in R. Or everybody should just use R, Python. They should just do stuff in C++. We have to remember that this is a really difficult skill set, and for a lot of people who've been working with Excel for years and years, this is a very scary and daunting shift. It's a completely new way of working, and so trying to be supportive of that rather than dismissive of previous ways of working is something that we're really keen to do, and trying to kind of bring people with us. So with that in mind, we're going to go through a little bit of the history of where we've kind of come from. So I'd say roughly 2020, the focus in our sector in kind of academics and groups within health economics was around publishing new innovative methods, publishing things like algorithms and software packages to do survival analysis, to do value of information, and writing publications on those methods and saying, look, here, you can do this stuff. This is really cool. Isn't this great? Shouldn't everybody be doing this? And that was kind of maybe pre-2020. Some people might disagree with the exact timings, but there was a kind of a lot of that going on. And that gradually shifted and morphed into kind of around 2020, a little bit before. There were some courses going on, but certainly during the pandemic and just after the pandemic, absolutely loads of online training going on using these publications to say, look, let's roll out this training. You can do this. You can come and learn from us on how to use these methods, so how to use Shiny for models, how to build models as packages, how to build your first model in R, how to utilize all of these cool publications that people have done previously. So that was kind of this middle process. And now what we're really seeing since about 2022, 2023 has been adoption. And really over the last couple of years, we've seen a massive ramp up in the demand from specifically the pharmaceutical sector, but also from universities, ERGs, who are building models from the other side for regulators to start building either in-house models or models for submissions to a regulator. So we've really seen this ramp up in kind of initially publications and cool methods pieces that was very academic to proliferating that through training, online courses, building it into MSc programs, and now kind of wider adoption as there's just more and more people within the industry with these skill sets, and they're all saying, yeah, we should do this, we should collaborate on this. So it's been really nice to see that happen. In terms of specific kind of milestones, there's some made a diagram here just showing kind of some key points along that journey. So as I mentioned before, some key software packages were made available as R packages on CRAN with associated publications. So FlexServe package, some of you might be familiar with, HeMod, and along with that, small groups of academics, largely initially, formed the R for HTA Consortium back in 2018. And that's kind of gradually grown over time. And over time, that's extended beyond academic groups and PhD students to consultancies and industry. Training then started to ramp up with the DART group in particular, doing a lot of training at conferences and at their own courses, which are now online as well. We published the paper on making health economic model shiny in 2020, and then developed a series of online shiny tools. So the Quali Shortfall tool, which is available by York, and the DCEA, so Distributional Cost Effectiveness tool, also available hosted by University of York. And those are kind of open source tools to allow people who aren't R programmers to make the most of new kind of methods. And so we kind of went from some academic papers, the start of kind of consortiums and groups and some teaching, some open access tools, and then kind of lately we've seen things like nice pilots, the Pathways R model for renal cell carcinoma, multiple R submissions in the last few years, including discrete event simulation submissions in R, amongst others. And then this year, again, multiple R submissions and an R for HTA book being published. So we really have shifted from academic through right into kind of industry and regulator widespread use. And so then in terms of our kind of small role in that, so we wrote the first paper back in 2020, and we've now developed that into a popular short course, which has been taken by a huge number of people, hundreds over the last few years, and that's now online. We've made all of these papers open source and open access. So we initially started with the shiny topic, then we tried to look at could we build out a living HTA framework where we had everything automated. And we did a load of complicated stuff with sending API requests with the model to the data so that we didn't have data security issues. It went way over everybody's heads, and really didn't land. And it's only now just kind of started to come back into fruition. We also developed a course for how to build a health economic model as a R package, which is gradually gaining traction, but again is nowhere near as popular a course as the shiny course that everybody loves. We developed some software that Wales going to discuss later on the Assert HE package to help improve quality assurance of models. That's kind of how do you review R code. And then most recently, we've working on a publication on kind of how do you automate out these reports, coming a little bit full circle back to the living HTA stuff, but using generative AI to automate out some of the text updates along with Quarto and Markdown. So it's kind of a bit of a timeline of our small role in this process. I'm going to hand over to Wale, who's going to talk a little bit about some of these papers and kind of go into a bit more detail on them.
Thank you so much, Rob. Well, there are a few, well, not a few, but quite a few early publications. But just to name a couple of them, starting from 2017 with the HeMod paper that introduced, well, the HeMod package, which was primarily at that time published for Markov state transition models, over to the microsimulation tutorial paper by Eileen Camp and her colleagues, which again introduced a step-by-step guide on how to build microsimulation models in R, and it extended the a looping through patients and introduced the vectorization uh, functionality into microsimulation models. And then over to the paper published in 2019 by Devin and Surti and colleagues, on which was nicely titled as "Are You Still Using Excel?", which again outlined a number of available software in the field that plenty of modelers had already started using, and kind of encouraging people to make use of script-based models and stay as well and start moving away from Excel-based models. But well, obviously there are plenty more papers, but we're going to try and focus a little bit on tutorial papers that we have published and that are relevant to today's talk. Next slide, please, Rob. The three key tutorial papers that we've published, again, as you will see in a second, had kind of they've grown popular to the extent where we've started teaching them in live courses. But obviously, because of the the timelines and the time zones, sorry, for of those participants who were interested in the courses, we then moved from teaching those courses live into a synchronous mode, especially for the making health economic models shiny paper, which gained quite a bit of attraction. And just to give you a brief overview of the value each of these papers kind of introduced. Let's move on to the next slide, please. So the making health economic models shiny by Rob and Paul Schneider, who is not with us here today, which was published in 2020. At that point in time, there were a few models that, I mean, they were programmed in R, cost effectiveness models that were built in R, and they had a shiny interface that was kind of trying to allow more accessibility to the code, but it was still the overarching kind of thought, or the theme that was linked to R, or the adoption of R, that R was being viewed, especially by non-programmers, by people who are not technical, as some sort of a black box. So models were treated as black boxes because people were not used to looking at the code. Some people did not understand the code. They were health economists, but were not trained in programming. So this paper was the goal of this paper was to show people that there is a kind of a point and click functionality that could be bolted onto an R model or an R-based model, and it wasn't a very difficult task to kind of not even a difficult task to kind of build a shiny app on top of the model. It might be difficult if you wanted to go and make it a fancy app, but just to have a basic app, it wasn't that difficult. And the paper actually went through a case study and in a step-by-step guide broke down the process into a nice kind of uh, infrastructure or architecture, which is nicely presented by this diagram, which is part of the paper, where they kind of try to take the readers through a kind of simple set of principles. What constitutes a user interface? What do you want the user to kind of be able to change? Those are considered shiny inputs. And then there is a back end where you've got your model and you've got other inputs that you're not expecting your user to kind of change. And well, obviously those inputs together with the inputs that are coming from the user interface, they're passed into the model, which is again a simple or a nice wrapped function. You execute the function in the back end. You well, process the results that are coming out of the model, and then you send them back to the user interface and present the outputs of the simulation, in this case, the cost effectiveness analysis, as either plots, diagrams, or even tables. So the goal of the paper, and which was I think based on how the number of citations that it kind of attracted, and the number of attendees that we've seen in the courses that were kind of brought in, or where they kind of had they bought into the idea of using Shiny as a bolt-on on top of the of an R model. Seems like a very successful paper, or a very useful tutorial paper. If we go move over to the next slide, please. In the following years, or 2 years later, we published another tutorial paper which was called Living HTA, and the goal here was to introduce two things. First of all, avoid the limitation, which was probably well, exclusive to Excel models, where data, even sensitive data, had to go with the model. And the second was to have a kind of a quick way to generate reports, update the model, and this is what the Living HTA automating health economic evaluation tutorial kind of introduced, which first of all, the idea was to write a script, your model, separate from the data. You can have dummy data that represents the structure of the real data shipped with the model, but have the model separated from the data, have the data and sensitive information hosted in the owner's servers, and you will have a nice API, an application programming interface, that communicates, or that takes on the model, or receive the model from the consultancy, from the health economist side, sends the model to the data, or grabs the data that's required for the model to operate or to run, runs the model, and then sends back the results to the consultant, the person, or the entity that requested the data to be used. And again, this is a quite unique at the time of publishing the paper, in that we had this allowed then the models to be open source if the developers wanted to, without any implications of the sensitive data being in jeopardy of falling onto the wrong hands. It also allowed people to update or to create this living HTA concept, where you can have your model update, or you can have the reports that are generated out of your model update as soon as either periodically, or as soon as the background data, or the patient level data kind of have updated, either because you've got a long clinical trial that is being still running, and you're expecting data to come in through the way. Now, in the next tutorial paper that we published in 2023, the idea that was that now we've seen that well-structured cost-effectiveness models in R look very similar to R packages, and it was very easy to kind of transform them into an R package, and the advantages of having them as an R package were immense, including, obviously, but not limited to, having built-in unit tests, which kind of from a software, or from a software perspective, what was quite a powerful thing is to make sure that the piece of software you're writing, the functions that you're building, the cost effectiveness or the health economic functions that you're writing are fit for purpose. They're doing exactly what you intend them to do. And this also, again, linked back with a previous paper, where we could show that if you had this in a package, you can include dummy data with the package. You can include documented. You can document the functions, all the functionality that's related to your model. You can document the model itself, including the assumptions, and the structural data assumptions, or the structural assumptions that you've included in your model. And obviously, if having it as a package, you can also include the functionality of requesting the original, or the sensitive data, the true data, not the dummy data, from the proper sources, and be able to kind of run the model using that data when you have uh, the credentials necessary. So essentially, if you're NICE, or you're a reimbursement agency that you are expected to run the model using the true data, or the actual data, then you would have the credentials, and you can use the model in its package form. And this was the key selling point, the key message that was in this tutorial paper. you will see that there is an emergent pattern here that we've been well seeing that there were issues in the field that we're trying to sort out. We've got quite a few tools at hand, and we then write a paper to explain how we use these tools to sort out these issues. But then we kind of found that there are some we didn't have some software, so that's what we did in 2024 when we kind of went ahead and created the Assert HE. But we've all been in this position where someone would come in and say, "Would you please review my code?" And yeah, well, you haven't seen the code, but uh, it might be your job, or it might be, for example, I work in a company. We've got a few streams going on, and I may not be involved with other streams, but I could be involved in reviewing some of the code. And obviously, well, the code could be massive. Like you can see here, different scripts. One script could go uh, for hundreds of lines, and yeah, that could be me. Oh, this was me at some point in time, having to review a lot of code. And this is where AssertHE comes into play, where we've thought about what would work well for us if we're going to review some code. What should we do? So in 2024, we kind of got into a stage where we've kind of created this piece of software, the AssertHE package. We've written a paper explaining how it works and why we think it's useful. And I mean, the audience targeted by the who we think should or would benefit from this tool. We've published it on CRAN, and we've obviously have a GitHub kind of web page that would explain to you, if you don't want to kind of go ahead and install it, but you want to understand what it does first, you can go ahead and read through the functionality that it provides, different functions and what they do. So, but what is the CertHE? So the aim was to allow reviewers and people who have built the health economic model in R to be able to do this process seamlessly. So for those who are building the models, we wanted them to be able to make sure that again the code that they're writing is actually doing what they think it's doing, and they would have checks in there, asserts, as we would like to call them, or as it's called in the field. So we wanted those who are building the models to be able to assert that they're either the inputs that they're coming into their functions, or the outputs of some of the code that they've written well, conforms with what they expected to conform. For example, probabilities fall between 0 and 1, and if in a transition probability matrix they sum up to 1. And if it was a transition probability array, then I want to make sure that all the slices are again correct. So this is for those who build a model. But again, we're also keen, and we're also interested that in making the life of those who were reviewing the code again much easier, by making sure that they could have a kind of a quick way to understand how the different functionality in the model, different code pieces, different functions come into play together. And this is what we've done. We've also included a little bit of help in the form of link to the or some of some sort of integration with large language models. But again, this is a quick overview of how you can start using AssertHE now if you would like. You obviously install the package and then load the library, and you can see here we have two routes, either as a reviewer. So route A, that would be you, and you can simply fire off the visualize project uh, function. And as you can see here, we did not say visualize package or visualize model, just knowing that some people in the field have not moved over to packaging their model. So this would work if your model is a package or it was just an R project. All you need to do is to give it the project directory, what folder your functions are in, and which folder your unit tests are in. And if you don't have unit tests, that's fine again. It will still work. And if you want it to tell you how much coverage you've got, it will do that. So for the again, once you run that function, you'll see this nice network which tells you exactly how your different functions are linked. The centrality of the nodes, like the one that you see in the middle here, the wrapper function, is based on how other functions communicate together. So the wrapper function, which we envision here, is the function that calls all other functions in your package or in your project. It's essentially it's your model. Would be the central. It will be the bigger node, and it will show how other functions are being called from it. And once you click on any of the bubbles, you will see this nice kind of pop-up window where it tells you the name of the function. It allows you to either access the function code or just view it in within this nice based interface, which is based on Shiny. And if you would like to actually look at it in the RStudio, you can click on the arrow on the far end in each of the lines and the corresponding lines. And if you click on the blue robot kind of button there, you would see this will then fire off a message to the LLM. Essentially, it packages it packages the function, its documentation, and creates wrap them together with a nice prompt, send them to the LLM, in this case ChatGPT, and the prompt will essentially generate a description of the function, what it does, and it sends that back to the package to assert HE, which kind of wraps it in the proper way and present it in this nice and neat window where it shows you exactly what in this case what this function should be doing based on the description, the notes that was provided in the Oxygen documentation, if you had any, or just by reading through the code and what the LLM can understood from your code if you didn't kind of document it in the way that we would expect you to do that. So this is what it would do. So now if you read through the paper, you will see that one of the case studies that Assertion was kind of applied on was the nice renal cell carcinoma pathways model or pathways pilot project. And this was a massive model. I think it was 25,000 lines of code, and this is how these different kind of functions kind of link together. But I will just leave it until you read through the paper if you're interested to know more, and I will hand over to Rob for the next slide.
Great, thank you. And just to show that how optimistic NICE were as an organization about the adoption of R, they actually called this repository NICE Model Repo. So yeah, that maybe shows maybe they thought there was only going to be one. Um, so in terms of that's kind of a bit of an overview of some of the papers that we've worked on over the years, and maybe people will have questions about that a bit later. But I thought it'd be useful also to talk about capacity building and training, because it's one of the things that isn't always like the most glamorous thing in conferences, because I love standing in front of a bit of software or a user interface or a really cool tool that I've built, and that's really fun to show. But it's one of the things that is kind of under discussed is how we're kind of building up capacity and training people in how to use these tools, because I really think that's the biggest barrier. So what we've done is develop a whole series of short courses over the years, and Wales alluded to that a bit already. Um, and over time, initially we had requests from companies, so big organizations. Could you do, a 2-day course on R just generally, or a 2-day course, 3-day course on Shiny? And so we'd run those live. So we'd be traveling down to London or over across the country to go and kind of talk at people for kind of a decent sort of 2-day slot. And the idea with those sessions was that they would be kind of a mixture of presentations and then exercises and workshop style format things for people to get involved in, so they could get their hands really kind of dirty in the code and have a bit of presentation, a bit of doing it themselves, a bit of assessment, really to kind of learn as they're doing. And so what we found over time is that we were just giving the same presentations over and over again, and that we were getting a lot of requests from abroad, and it was obviously very tricky to make these available and kind of fly out to Australia as much as I would have loved to fly to Australia to give the courses. It wasn't really very practical. So we transitioned them over to a short course platform so that now they're kind of pre-recorded sessions with exercises and all of those kind of things built in as you would do with Coursera or any other course. And that's gone really well. So the interest has been really strong in that. You can see here the number of active enrollments across the courses and active users kind of gradually ramping up. We put the courses on the platform just over a year ago. Before that, we were primarily teaching kind of in person or kind of online, giving the sessions live, and had been doing that for about 3 years before we finally took the plunge and put it on the online platform. And since then, it's really taken off. There's a huge amount of interest in using R. This has kind of coincided with the Gen AI kind of boom, where people suddenly have access to a lot of these LLMs via, ChatGPT and Claude and others, and so people are very keen to learn how to code, and to have essentially a coding assistant alongside them has been great. The other thing we've really noticed a difference in since over the last year or so has really been the types of questions that are asked. Because we have this course platform, and the format is typically something like this. So for any given topic, so say for example Shiny, the sessions are generally split into several different topics, and then within each topic, delegates watch a bit of the presentation. And that might be kind of an overview of why they need to learn this thing and how this fits into the broader picture. And then generally we'd walk through the code and explain the code and run the code live in a session and kind of demo that. And then ask delegates to try it out themselves with exercises and solutions provided. And then we have this live component, so in kind of person on Zoom or Teams or whatever it may be, where they actually come one-to-one and ask questions. And what we found over the last roughly year, 2 years, is that the types of questions have really shifted. So previously, when we were teaching, a lot of the questions would be, why doesn't this bit of code run? And the answer might be, oh, you've used the wrong type of brackets or something like that. We don't get any of those questions anymore. The use of generative AI has basically meant that people can paste a bit of code in, and they get a pretty good answer as to why that line of code might not have run. That's probably going to cover 95% of the errors. So we don't get any questions like that. All of the questions now are around the top level, understanding how to work with clients who are using R or on a specific project, and how the actual programming components fit into the project, how we make things more usable, how we make things more transparent. So the really kind of more interesting questions rather than the kind of nitty-gritty, the commas in the wrong place type of question, which has been really nice. But probably the most rewarding output from these courses has been having people hands-on. So this is a screenshot I take at the end of our Shiny course, where delegates share the app that they've launched on their own shinyapps.io account. And so yeah, every year we run this and have kind of our delegates share the links, and I kind of show them all up on one screen, and we can kind of see what they've launched, which is really cool. For those of you that are interested in learning more about kind of the R methods, feel free to have a look at our reading list. We can share the link a bit later. But we have a reading list for those people that might not want to or can't for whatever reason join the courses. We've provided a list for all of the open access and open source papers about R for health economics, for those that want to kind of self-learn. So just before we kind of finish off, we've talked a lot about kind of the background and some of the academic publications we've done, and I wanted to discuss some of the platforms and the Shiny apps that we've been working on, just to give a flavor of the types of things that we're doing to help this transition away from Excel and to make things more usable. And really, Shiny does play a absolutely crucial role in this. There's a really nice quote by Chris Whitty back in 2015, so long before the pandemic, in which Professor Sir Chris Whitty was the Chief Medical Officer in the UK. And he's got this really nice quote that authors of modelling papers can do things to make their work substantially more useful for policy, and really that the best is to provide an interactive interface where if the policymaker doesn't agree with his starting assumptions, they can change them. And really, what I think people are trying to get at here and why this is so valuable is that often when we're displaying the results of analyses, um, and say a minister or politician or any decision maker is reading that, there's a certain amount of trust they have to have in the selection of parameter values, the structural assumptions, all of those kind of things. And ultimately, you can lose the decision maker on the basis of a single parameter selection or distribution selection. And often some of those assumptions and decisions don't really have that big of an impact on the paper or in the results, but the decision maker kind of gets distracted by that. And so what I found is it's really valuable to use things like Shiny to host models so that you can really have that discussion and say, okay, so does this parameter even matter? And it might be that quite often I find that the parameter that the decision maker was really fixated on, you go and change it and rerun the model live, and you realize that it doesn't really change the decision. So it was a distraction. But by doing that, you've avoided having your report that took you weeks to write go in the bin. And so that's kind of really where I've seen Shiny be incredibly influential. So when we wrote the first paper back in 2020, we also built, Paul Schneider and I built an open source Shiny app just to show kind of what's possible and functional, and built in some cool functionality with an R package we developed that uses C++ to speed up the model runtime. So typically these Excel models that are being built might take 3 or 4 hours to run what's called probabilistic sensitivity analysis. So it's running a large number of simulations through the model with different parameter values randomly drawn from fixed distributions. And so quite commonly 1,000 or 5,000 iterations will be run through. And in Excel, this, as I said, often takes 3 or 4 hours. In R, this can be done in seconds. And so that really shifts things from being something that you have to do kind of yourself, it can't do in a 1 hour meeting, to something that can be done on the fly in a meeting after changing a parameter quickly and then having a discussion about it. So that was one of the really big wins for R, is having Shiny to be able to do that. We've also used it quite a bit in training tools. So we've got one training tool that we built a while back, which essentially is used as kind of a gamification of learning what a health economic evaluation is. So we've got this tool that kind of you work through it and you do these little exercises. So in this slide, it's like change the number of PSA iterations and look at what that does. And by making it kind of a bit of a game inside of an app, it just makes it a lot more friendly rather than kind of giving somebody a large PDF to read. So that's another way that we've used Shiny in health economics to kind of break down that barrier. And the really big benefit here is, meanwhile, this is kind of running our code in the background, so people are getting familiar with these interfaces as a concept as well. We've also been able to do some other things that we might otherwise not be able to do in Excel. For example, here's a really nice app that we built as a prototype to display how we can improve access to healthcare facilities in the UK for different treatment types. So for a given treatment type, say HIV, you might have different modes of administration, some of which require you to attend a hospital. Others you might be able to do your local GP or pharmacy. And so really understanding how we can improve access can help with that. Something that you could never really do or implement in Excel with a map, but you can implement in R with Shiny using the leaflet package. The same for some of the other tools I mentioned before, the DCA tool and the shortfall tool, which are very simple tools, but just having them publicly available, anybody can log on, play with them, has been super valuable. And finally, the last one I'm going to mention is the structured expectation tool that we currently just launched, which allows you to take estimates of distributions and parameter values from experts live, and it kind of automates the sending out, like SurveyMonkey, of all the emails to different experts, but also the linear pooling stats work gets done within the tool itself, and that uses open source R packages being called via API calls to where they're hosted on the servers. So the app itself is not actually built in R or Shiny, but it's relying on open source R packages, several open source R packages, to do all the stats work underpinning the app itself. And then the benefit of that is that when submissions get made to regulators, they can just say, look, this is the exact code we've used. It uses this open source package. If you want to replicate the analyses, you can replicate them exactly on your RStudio positron. You can replicate them exactly and get the exact same results. We've just done it in the platform in the app for convenience. So just before we finish, I think about right on time. The really big shift that I've noticed over the last 2 years has really been the use of Gen AI day to day. Firstly, by individuals, so by people who are working in industries or in universities, consultancies, who are just using it day to day to figure things out more quickly. And what we found is that the coding ability of the average person has improved significantly. So it's really helped people. The second thing that we found is that the way in which more proficient people who are kind of at the forefront of Gen AI or working on Gen AI for health economics, the way in which they're able to interact with code versus spreadsheets is quite significantly different. So we've worked on projects in the past where we've been collaborating with people who are trying to automate updates to Excel files, and Gen AI really struggles with that because there's a visual component. So if you have a label in Excel, it's hard to know which cell the label is referring to because the label could be above, could be to the side, there could be a gap in the cells, and so there's this visual component to an Excel file, Excel worksheet that we find hard as humans to recognize how this would be tricky for a generative AI tool to understand in a way that just isn't the case for script-based models where you're clearly defining every object. So I just leave with that, saying that that this is really speeding up the transition towards R, and I'll leave it there.
Okay, gentlemen, I think maybe that's the end, and we're going to go into questions. Thanks, Whale and Robert. Feels like a real tour de force. There are multiple points that I was personally interested in, including uh, questions, support questions, no longer focused on, details in the code. How do I run this? Because they can fix that using AI. Super interesting. And then also being able to provide the shiny models to policymakers. It's fabulous. We have questions coming in. I'm going to read some of these out from people attending. This one's from Anonymous. Hopefully we'll get to this, but I'm curious how our models are more transparent than Excel models. In my experience, the opposite is true.
That's a good challenge. So there's a number of ways that we've seen them be more transparent. Obviously, it depends on who's built the model and what methods they've used. So a poorly built R model is of course going to be worse than a very well built Excel model. But in general, what we found is, firstly, it's very easy to share code online. So we can share all of our code on GitHub, and we can also utilize components and algorithms and functions from other packages that have already been, let's say, validated or heavily used by the research community, so that we're not having to reinvent the wheel on every small component of the model. Um, we've also found that it's very easy to test small units of a piece of code if it's well constructed and built in a package, like Wela said, so that the burden of validation really falls on the developer of the model, on the original modeler, and the reviewer is simply reviewing the testing that's been undertaken and assessing whether the testing is appropriate and whether the function has been used appropriately in the correct context, rather than having to actually go through and test all the edge cases. So those are kind of two ways in which it's more transparent. The final thing I'll mention is just the sheer volume of cells that have to be reviewed in a given model. So we recently translated a Excel model from Excel to R. It was a model developed for ISA in the US, and I think we found it was about 8,000 cells per line of code. And I don't know about you, but I'd much rather review one line of our code than 8,000 cells. Even if you can sort of drag and drop things, it's still a lot of equations to look at. I don't know if that answers the question. Or...
Well, they're able to come back with more,
Yeah.
but I'll go on to the next one for now. This is from Tome. Have you tried this framework allowing HTA agencies to use external sensitive data to create PSAs that use bootstrap sampling using e.g. RCT or RWE data? Would it be fast enough to be an option for HTA submissions in practice?
Give that one to Whale.
Yeah, thank you so much, Rob, and thank you, Tommy, for the question. We haven't been successful at kind of convincing reimbursement agencies like NICE and Zen to kind of use this kind of framework. But I think, yeah, the more people adopt these kind of frameworks, as in build a model, allow the model to access data from external sources, and then hand these kind of models to the reimbursement agencies. Then allows them to use the functionality if it's available. But if the functionality is not available to begin with, so the consultancies who build the models haven't yet kind of adopted this kind of framework, it might take some time before they kind of use such functionalities.
In the meantime, the functionality that we've basically been building in is to share the code with some dummy data, as Whale alluded to, rather than using any of the API calls, which is where I think we've just struggled to articulate the value, or people have not been willing to do that. We've just avoided that by essentially just sending over a separate data folder. So you have one data folder that's dummy data that you could make kind of more open, more transparent, and then you have another data folder that just overwrites the dummy data with the real data, and that's the way that we've typically worked till now, and that is generally fine. Avoids the needs for API calls and things like that. Works Yeah, it's fine if you only need to run the thing every 3 years. If you're running it daily, you don't want to be emailing around a ton of data or showing a ton of data on SharePoint and stuff like that. So yeah.
Okay, next one from Anonymous. How do these pre-built R packages, Shiny apps, deal with complex models? For example, varying stopping rules, different definitions of treatment effectiveness, waning of effect, inputs varied jointly in sensitive analysis.
Yeah, so that's a thing that we commonly get questions about. So within the R for HTA or R for health economics community, there are some people who prefer to use like an existing package to build models, so something like HeMod or HeSim, if people want to look those up. And they're essentially model building packages, so they kind of instruct you on how to build. They provide a template, instruct you on how to build the model, and you use those packages to build the model, and you're kind of fixed within that framework to some extent. And that they're really useful if your model kind of if they have all the functionality your model needs. If your model has some weird quirk that means it doesn't fall within that framework, then they can sometimes be trickier to use. For a lot of the models, it's absolutely fine because they all follow them a similar model structure. But if you have some quirk to your model, then they can be tricky to use. What we tend to do, because we get a lot of strange models, because people have come to us in part because we don't we don't typically do the bulk of the kind of simpler models. We tend to build everything from scratch in base R and C++. And then you have the full flexibility of doing whatever you'd like. Because even if you initially think, oh, this is a straightforward model, at some point in the future, the client might suddenly say, oh, could you introduce this strange stopping rule combination with this, combination with that, and then suddenly you kind of put yourself down a route where you can't get into building that functionality, or where it's very tricky to do that. So yeah, so we've typically built things in base R ourselves. Jesse, you mute.
Thank you. This one's from Daniel. Thanks for the great presentation. I've noticed that the don't repeat yourself principle does not tend to be reflected in the programming and data organization in many of the published R models. Two examples. one, the micro simulation tutorial, and two, the nice RCC model. Is the use of a scripting tool itself sufficient, or is there a need for greater standardization?
Yeah, I think that's an excellent question, and probably the dry or don't repeat yourself concept is something that yeah we need to emphasize in the field. But I think one of the selling points of using functional programming is actually not to repeat yourself, or not, I mean, to use to employ the dry concept. And there have been a few papers. I mean, even the packaging cost effectiveness modeling, the packaging cost effectiveness model tutorial paper was one of them. It was the second paper to kind of allude to that kind of concept. The first was the need of change paper by Fernando Alrid and his colleagues. But yes, we needed standardization in the field. We've tried to kind of hint at, yeah, we need to follow functional programming, use functions and use functions that do things well, do one thing at a time, and unit test those functions. And once you have that function or that functionality kind of wrapped in one function, then and that function had been kind of had its own unit test, so it's been properly written, documented, tested, then well, the obvious thing would be not to repeat that code, that piece of code, out of the function, but just reuse that function. So I think we've tried to kind of and not only us, but Fernando and his colleagues, to kind of yeah, put forward this notion that functional programming is essential, and within the merits of, or the within the framework of R packages, is excellent, and we should always use that.
Okay, I think that's it for questions. There was one person asking if slides will be available. Whale and Robert, will you be making these available?
Yes, yeah, we can make the slides available. That's absolutely fine.
Okay, and along
Yeah.
with that, the R Consortium will provide this recording, so you'll have the whole recording, and maybe we can link to the slides that way as well. So the quick answer is yes. Okay, so I think we'll finish here today. Thanks very much to Whale and Robert. Really appreciate the time and effort and the depth of information here. Thank you, gentlemen.
Thank you.
Thanks for having us.
And thanks
Thank you.
everyone for logging in and checking out. Thank you very much from the R Consortium.
Thank
Thank
you.
you.
Goodbye, everyone.
Bye.
Bye.